This is Algebra 1B Part 1. We're working on Unit 1, Lesson 4, which is a review of linear functions. So again, we continue our review of Algebra 1A material. Linear functions. So a function is kind of like a machine. It's an input-output device. Let me demonstrate with a little bit of a graphic. So we have this machine or box. Okay, it has input, so we can take numbers and put them in. X goes in. Kind of reminds me of the movie Chicken Run. Chickens go in, pies come out. Okay, turn the crank on the machine, and out comes Y, or f of x, right? The input, what goes in, is called the domain. The output, what comes out, the y output, is called the range. It's also called the independent variable and the dependent variable. So there's a lot of vocabulary associated with this. And the notation can look like this. It can be a table. It can be a formula. It can be a set of points, right? So let's say I've got this point here. I've got x and y, so I'm going to represent a function as a table. 0, 1, 2, 3, 4. And y is 2, 4, 6, 8, 10. Okay, so this is one representation of a function. Okay, we can represent it with ordered pairs. We can represent it as 0, 2, comma, 1, 4, comma, 2, 6, comma, 3, 8, comma, and 4, 10, comma. Okay, we can also represent it this way. You have the formula y equals 2x. Okay, and you can verify each of these points, right? We can substitute values. So for example, if I put 1 in for x, 2 times 1 is 2. Whoops. What? 2x plus 2. I'm missing part of the formula. 2x plus 2. Good catch. So if I put in 1, I get 2 times 1 plus 2, which is 2 plus 2, which is 4. If I put in 2, right, I get 2 times 2 plus 2, or 4 plus 2, or 6. So I get out the output there, right? So input yields output, input and output. That's the idea of a function, right? Input x, output y, or output f of x. And this notation, f of x, I said y equals 2x plus 2. We can also write it f of x equals 2x plus 2. That means a function of x. F is a function of x. All right, it depends on x, the independent variable. All right, so here are some examples of some things you're going to need to be able to do with linear functions. Okay, evaluate. The word evaluate. So if we're asked to evaluate f of x equals 3x minus 4 for x equals 6, what it's asking us to do is substitute. If x equals 6, where you see x, put 6 in the function. So we get f of 6 equals 3 times 6 minus 4. And it's a good idea to put parentheses where you do substitute. Okay, especially if you're substituting a negative number. 3 times 6 is 12. 12 minus 4 is 8. So we say f of 6 is 8. And that corresponds to the point 6, 8 if we were to graph it. Okay? So that's one thing you'll be asked to do, evaluate, which is really to substitute and simplify. Substitute and simplify. Okay? Another thing you might be able to be asked to do is to complete a table. I call it a t-table. All right? So we can complete a t-table for a function. So let's say, for example, I've got the equation, and you can do it y equals or f of x equals. Sometimes you're going to see it y equals, so we'll do this one, y equals 3x minus 5. And we're going to complete a t-table. So we're going to choose some values of x. I'm going to choose 0, 10, 20, 30, and 40. Okay, and y, we get to calculate. One at a time, we're going to evaluate the function for these values of x. Okay, and you can do this in your head, you can do it on paper, you can make a 3-column table. I'll go ahead and do the substitution. 3 times 0 minus 5 is 0 minus 5, and 0 minus 5 is negative 5. 3 times 10 minus 5 is 30 minus 5 is 25. 3 times 20 minus 5 is 60 minus 5 is 55. 3 times 30 minus 5 is 90 minus 5 is 85. 3 times 40 minus 5 is 120 minus 5 is 115. Okay, and I know I'm going a little quick, but it's review, and it's also by way of introduction. You'll get more detail in the lesson, but you can see how we generate all of these points. These correspond to the point 0, negative 5 on the graph, 10 and 10, 25. Okay, 20 and 55. And if you need to, if you're taking notes and need to pause the video, go ahead and do so anytime. 40 and 115. Okay, so this corresponds to points on a graph. All right, the next thing we need to be able to do is to turn a word problem into a linear function. And there are some hints in the word problems that'll help you out. Okay, so here's a problem. Molly earns $11 an hour at the cheese factory. Okay, she has $250. Okay, write a function for how much money she has. Okay, now linear functions are all functions of this form, y equals mx plus b, where b is the start value. It's also called the y-intercept. And m is the rate, also called the slope. When you see things like miles per hour, feet per second, dollars per hour, pounds per square inch, right? When you see the words per or an, a rate is being implied. So we can look at the word problem and take some hints. $11 an hour is a rate. This is a rate, and this is the slope. Okay, that's the slope. She has $250. That's the amount of money she is starting with. That is her y-intercept. Okay, so that is b, where this is m. So really, it's not terribly hard to first recognize it's a linear situation because there is a rate involved in the problem and a start value. And then second, to use y equals mx plus b to write the equation. Y equals m, 11, x plus b, 250. And we can express it y equals, we can express it f of x equals 11x plus 250. Now, one of the things we love to do with word problems is when we write the function, make it mean something, right? So I might use A for the amount of money she has, And I might use t for time in hours, right? So a equals a of t, amount of money as a function of time, is equal to 11t plus 250. So you can use different variables than x or y. It doesn't have to always be x or y. The letters can mean something in the context of the problem. Okay. One last thing you need to be able to do, and that is, given a set of points, you'll need to be able to write a linear function for it. So here we go. Let's go and do that example here. And this is a longer video than normal because we're doing a lot of problems here. So here are a set of points. Okay, 0, 2, 2, negative 2, 4, negative 6, and 6, negative 10. Okay, we kind of practiced this in our group live lesson this last week here on Tuesday. So here's what I do, and it helps. It's helpful if you can graph it. You don't have to graph it, but it's helpful if you can graph it. And actually, we're going down to negative 10, so I need to move the origin up higher a little bit. So 0, 2, 2, negative 2, 4, negative 6, 2, 4, 6, 6, negative 10. Whoops, I didn't go over 2. 2, negative 2, 4, negative 6, and 6, negative 10. And hopefully you notice something about these points. They all seem to be in a straight line together. Okay, and that's by design. So it is a linear relationship. And it's a linear relationship because the rate of change, the slope, is constant. It's not changing. Okay, now I want to note something about this. First of all, there's two things I need to know to write the equation in y equals mx plus b form. I need to know the start value, and that is the y-intercept. So the start value is 2 because it crosses the y-axis at 2. There's another hint. The x value on the y-axis is 0. So as a point 0 comma something is always 0 comma b. It's always going to give you the y-intercept. Then we got to figure out what it's doing. What's its rise? What's its run, right? Because slope is rise over run, change in y over change in x. So it's going down 1, 2, 3, 4, down 4, and over 1, 2, over 2. So the slope is down 4 and over 2. Okay, now we can leave it like that, but I would prefer to simplify it. That is 4 divided by 2, and 4 divided by 2 is 2. A negative divided by a positive is a negative. So this has a slope of negative 2 and a y-intercept of 2. So I can now write my equation. Y equals negative 2x plus 2. Negative 2x plus 2. Or we can write it as a function. F of x equals negative 2x plus 2. All right, hopefully that serves as a good overview to help get you started, and also maybe a point which you can return to remind yourself how to do some of the things in this lesson.